Okay, so good morning. My name is Maciej Kaczynski. I'm a senior project leader here at Studio Gang. Big thank you to the folks at Boston Valley Terracotta and the University at Buffalo, and of course Carnegie Mellon University for inviting us back to participate in this year's event. I'm presenting, of course, on behalf of a much larger team than just me, just myself. We're of course led by Jeannie Gang, and on this project, Weston Walker, who worked closely with us, and the engineers at Walter P. Moore. So thank you to the entire team. Our research is a continuation of last year's ACAW. More about that in just a bit. So let me begin with a quick recap. So at Studio Gang, we work on architecture and design projects at many different scales, from prototypes to towers. And regardless of scale, a common link across these is a interest and in material research and exploration. We're really keen in learning and understanding what things are made of, how materials work, how they break, how they perform, and so forth. Through material research and hands-on explorations, we hope to discover new and sometimes even forgotten ways to work with these materials. Projects like ACAW are a wonderful opportunity to build relationship with and learn from material and fabrication experts. So of course, we're very thankful again to be here. We've had some experience working with terracotta as a facade material. We teamed up with Boston Valley on this project. This is Rescue Company 2, a training facility for FDNY. We were super thrilled with the collaboration and the result, but I will admit we were also astounded by the complexity and the sophistication of the clips and infrastructure hidden behind the facade necessary to hold the panels up. ACAW is an opportunity and present us with the opportunity to get to know terracotta beyond the facade. And so we became really keen to learn, like, what other applications can we find historically that terracotta has been used, in this case, structurally. We were super thrilled also to learn about the historical heyday of terracotta, and certainly Chicago played a big role in that, with a lot of civic buildings. But let's not forget also that terracotta was not always, even in its heyday in the 1930s, say, always a facade material. It did play a very, very important role in fireproofing and even permanent structural formwork. So this led us to our question, how can we scale up terracotta construction? And perhaps in parentheses, as a side goal, how can we also perhaps reintroduce past structural applications? Here's a super early sketch where we were trying to see if we couldn't find some ways to actually begin to just aggregate components. And very early on, we saw an A and a B kind of emerge, and also a desire to tension them together. So from a smaller unit that is handheld that can be fabricated into a larger assembly of some kind, say, like at the time, we were thinking of a monolithic mega panel of some kind. That very, very quickly evolved into a semicircular arch. And we were super thrilled with that. And we were immediately looking at extrusions through a die. We settled upon that fabrication method. And also, as we began to refine the shape of it, going from a semicircular form to a more structurally idealized form, we were also interested in carving operations to remove excess material. So only have what's there, only put what's there. Here's the arch that we settled upon. This is from a year ago, fondly named Archie. It remained true to that form. It has some subtle changes, which we'll review in just a second, but this is sort of a recap of where we were at the end of last year's ACAW. We did do a virtual exhibition. It was the era of COVID, of course, and so everything was entirely virtual. And here you see the exhibition that showed off the actual assembly of the arch, the steps involved in that. It's easy to build an arch virtually. It's not quite the same in real life, starting with the extrusion. So this is a look at one of the extrusions. And if you were to look casually, it appears conceptually obvious, right? Clay plus pressure plus dye equals extrusion, but in reality, there's an extraordinary amount of craft and care and consideration that goes into every success. It's not something to be taken for granted at all. Matter Factory did have some difficulty producing this, and we learned a lot through them and with them, as much as we could virtually. And what we ended up doing was, at the end of the project last year, and being offered very generously by Boston Valley Terracotta to take on this extrusion and invite us back to continue the line of research. They sharpened their pencils and they remade the die, and they tamed the extrusion, which was super great. And we, of course, as one does, found more things that we had to solve, more problems. And so they said to us that it's not quite working. We're getting a little bit of a sagging issue as the pieces is coming out. And having some kind of fidelity for the unit was super important to us because, of course, even just a subtle change writ large could compound and make a very different arch. So we went back to the drawing board and worked with Boston Valley Terracotta very closely. And we investigated several options and settled upon a version that was both thickened, the actual profile itself was thickened, and also we reoriented some of these cells inside of the extrusion. This gave us our final piece. If you're looking at it on a monitor like I am, it's about that's about the real size of it. And importantly, the perimeter profile remained unchanged despite what was happening on the interior of that. Here's a view of the wire cutting operation and also the final finished piece. So after about a year plus of steady troubleshooting, we had pieces ready for the kiln. And over the course of our collaboration, of course, we as you just saw, we were making subtle adjustments and changes to the arch. And one of which that's also worth mentioning is that through that process of troubleshooting with Boston Valley, we began to have less confidence in our original joint connection between these blocks and decided that rather than the originally intended 1/4 inch neoprene gasket, which was always a little bit ambitious in terms of its ability to handle variation, we decided to go with mortar joints. More on that later. So now that we had the terracotta in production, we could shift our attention back to the rooftop here at our Chicago office, where we always had intended to build Archie. We were super diligent about finding the perfect location on the roof to make the perfect home for Archie, and made a mock-up to shift around and relocate across the roof, settled upon a location, and then quickly turned our attention to the base design. So we got real about the base pretty quickly, and what we realized is that there was actually quite a good reason to be using the deck, not just as a site, but also structurally. So if you look at the that slightly different shade of decking beneath the arch, that's actually new decking that we use as continuous boards to actually provide some resistance to splaying. If we look at the section of that, you can see you can of course see those boards that run continuously. And then if we zoom in toward the actual foot, you can see the large blocks that make up the feet that you can't see at all. And then these sort of quote unquote finished block up top. And here's a quick view looking at it from the side. You can see all the hardware. Another important thing was to make sure, of course, that you didn't actually penetrate the membrane that is protecting your building. So we were very careful about the proximities of these screws to the membrane. And here's a quick axon view of that, just to give you a sense about what we had. So as we were designing the base, we were, of course, in very close contact with our friends at Walter P. Moore. It's natural to assume that a 1,600-pound terracotta arch would have no need to resist uplift. But when we provided those dead loads to Walter P. Moore, they informed us that actually, in fact, there could still be some very windy conditions in a very windy city where Archie might actually drift slightly, pulling our deck with it. So not airborne we're talking, but still not behaving quite the way we wanted it to. So that was a really important moment. Actually, we sort of sharpened our pencils, and we were sort of later in the process too, frankly. And we really didn't want to be adding a lot of ballast. We certainly couldn't add it to the terracotta at that point. So we said, like, okay, there's enough deck here that it feels like we can do something with it. We can take more advantage of that. So we actually began to just have a more thorough connection, which was really just a few confidently secure members, additional sleepers, if you will, integrating it into the deck. Delivery day arrived. This was one of the first moments that we, aside from sort of just a smaller scale test, that we actually got to handle the material. It was a very exciting moment. We were also, I will admit, astounded by the scale of the pieces. They're always smaller in a computer in front of you. So we were super excited, and we placed the blocks out onto a full-scale print, and we wanted to confirm the joint gap is immediately, because that would let us, of course, proceed with the construction of the Falsework. So we carefully measured and labeled all the blocks. They're all identical, but we knew that we'd have some natural variation in them. And sure enough, we did find some pieces. We had extras. So we did find some pieces that we could set aside and not use. They probably visually even looked identical, but even just some slight measurement tweaks led us to put those aside and probably keep them as emergency spares. So Archie is essentially 3 projects in one. It's the base, which you barely see, which we reviewed already. It's the Falsework, which is temporary, and of course the terracotta itself. Each of which has its own special considerations, and building upon our roof required very careful attention to those existing conditions. So as a quick note, when someone says casually, when you're on a team in the future and working on a prototype and someone says casually, let's just put it on the roof, just put it on the roof is not a thing. It's much more involved than that. This was a heroic effort, and which Skylar you see here in the photo makes look very easy all the time. Here's the base block now fully concealed. You can see the new tensile members and the decking that's doing that. So the Falsework wasn't as instant as this presentation makes it appear. It was itself a considerable undertaking. It's a simple, though dimensionally demanding construction. So one very important ingredient of that is the shimming detail. And that's super important because we do need to place it very accurately in 3D space and have it sit very confidently so that, of course, we're not having any difficulties with doing the stacking. Here's a quick look at, you might recognize this. This was taken from our virtual exhibit from last year. It was also a handy reference. We could pull this up and say, you know, when we scratched our heads from a year ago and say, how did we intend to do that exactly? And we could remind ourselves. And so this gives you a sense about, it's fairly straightforward. You have centering, you place the blocks on top, but one important ingredient to produce that sort of monolithic post-tension construction is, of course, the actual tensile line. And you can see in here that tensile line is being pulled through the blocks as each one is being placed very carefully. Visible at the right there is that pilot line. So here's the very, very first block that we set up. So keep an eye on some of these photos that you'll see during construction, because that is a super important thing. I don't think we once lost it, but it was a bit of a nuisance to just continually fish through the blocks, though the payoff would be very good in the future. You'll see that in a bit. Here's that, you can see that line again, and that's, it's worth mentioning here that we actually had several joint designs and materials. I spoke a bit about this briefly earlier, but we ultimately found the most fitting material is also the most ancient, which is lime mortar. This gave us a couple of properties that we really, really liked. One was, of course, as I'm sort of suggesting on, is the ability to accommodate variations in the terracotta blocks themselves, to provide a long set time. This was important to maintain some level of plasticity for the tensioning process at the end. So we couldn't have all the mortar set up entirely. We wanted to give it a little bit of squish. And then also this lime mortar gave us confident adhesion, so that even as these pieces ascended to vertical, we could actually maintain, we didn't have to worry about it moving on us. During prototyping, we also found that despite lime mortar's long cure time, a very dry block will also make it cure much faster than you were expecting. So it was super important that we also just wet these down constantly, which was a constant task that we couldn't lose sight of on a very hot day. Here are several important and simultaneous steps happening. You can see Skylar and Juan on the left here, fishing that pilot line through the block and setting it in place. No less important is Evan's job in the middle there, keeping those holes clear of any extra mortar. Obviously, we can't pull that line through if it's not clean and clear. And Carlos on the right is laying the mortar up for the very next course. We were initially quite slow, but gained confidence as we moved up, literally. And right about here is where we began to lose steam a little bit, but we knew that we had to get all the pieces in place that day so that we had a little bit of control about the tensioning process the next day. So day one, set all the pieces. Day two, actually do the tensioning. It might look like a completed arch, but no, that's forgetting the most exciting part. One of the most exciting parts, that's the tensioning. And really, ultimately, tensioning is just an operation to link these two objects. This is, of course, the keystone at the top and the feet at the bottom. And connecting those two together is Dyneema rope. It's an extraordinarily durable material. It's resistant to loosening. It's stretch resistant. It was sort of a perfect fit. Here you can see Peter, our knot whisperer extraordinaire, splicing those ropes onto the keystones. Also note the black cover, which you should be able to see here around the white structural tendon. The black cover was there to actually protect the actual structural member. And there is good reason to do that because, of course, terracotta can also be sharp if you've handled it. Here's a view of those tendons spliced around the three keystones and a view of the keystone in place on the right. Note the unmortared gap. Now that gap there was quite important actually. So what we did was we placed these keystones with the tensile lines attached to that orange pilot line and pulled the entire thing down through toward the feet. So then we didn't have any pilot line, we just had the actual tendons in the arch, 6 of them in total. Once we had the tendons pulled down through the arches, we could then post tension them securely to the feet. So this happens with 2 lines, one that is temporary, that is applying the actual necessary force downward, and then another line that is actually linking those 2 together permanently. Note that we had, if you're looking very carefully, you may have noticed that we had in an earlier version of this, our tensioning operation happened with a winch. We realized that we didn't need a winch to do the tensioning. With some clever rigging, even puny Evan here could do the necessary tensioning operation. Here's a look inside the feet showing the permanent line. You don't see the temporary pulling line here, just the permanent line. So despite all that was 2020, we were thrilled to finally bring Archie home on the range, so to speak, on our rooftop. And we're also super excited to imagine the critters and birds and lichen and moss, et cetera, that we think are going to call Archie home in the future. You might be wondering, but wait, Maciej, when are you going to remove the Falsework? Is this a cliffhanger? It is a cliffhanger. Archie sits on our roof just like that at this moment. And on Monday, we decided that we were going to remove the formwork. And I'm sorry to disappoint you, but you'll just have to write us and ask us how Archie went. Or better yet, as we move past our COVID era, come and visit. Our rooftop is a semi-public space. We do host events there. So you can see Archie yourself in the future. And of course, big thank you to the entire team, which was a tremendous effort on all parts. So thank you everybody for all of your work. I won't name everyone because it is a large team, but that is the presentation, and thank you for your attention.
Maciej, thank you. That was, yes, thank you for the cliffhanger. Is this a way to sort of get into the next year's ACAW as a startup?
Correct.
Wonderful. Just in terms of some of the work that went into, let's say, just the redesign from last year and now as you're, I mean, because the design fundamentally didn't change, and I think you've just sort of perfected it. As you guys are now thinking about terracotta systems, and obviously this was a structural piece, what were some things that even in the assembly process, maybe you could share a little bit more that was learned, or you would redesign the original terracotta piece in any particular way?
Yeah, good question. I think, you know, if we had started from scratch, one of the things that we probably would have done was we're not super keen about mortar touching wooden pieces. We think there could be some liability to that. That feels like it's not totally appropriate, frankly. And we probably would have even made that into maybe say like one idea we were tossing around was a rubber connection at that moment, or perhaps even finding a different material, maybe casting it, the keystone, to make it appropriate for mortar to touch. So I think most of the lessons were coming from the actual connections. We had a variety of even when we settled on mortar, we had a variety of options we were looking at. We had mortar in satchels that we thought would make it a bit easier to determine to have a reliable gap. That ended up being way more work than it was worth. And we immediately, actually, we on the rooftop, we just looked at it and we said, this isn't going to work. Somehow it felt so good in prototyping, but we didn't even do it. And we just said, let's just do straight mortar. And we were really thrilled with that because, of course, that offered us just a lot more flexibility. So I don't know, there's also some humility in just, we spent a lot of time trying to reinvent some elements that were already abundantly apparent from history, like how to do them. But nonetheless, of course, it's still important to ask those questions. So we don't regret trying out and asking some of those questions. But it was a bit humbling to see, like, actually, this was solved hundreds of years ago. The answer is mortar.
Right, right. Well, thanks so much, Maciej. It looks beautiful, and do send us images, and we look forward to your participation in the book.
Thank you so much. Our pleasure.